Voyager 1 has begun transmitting puzzling signals back to Earth, signals that even NASA scientists are struggling to explain. Alongside its identical twin, this aging space probe has played a critical role in shaping our understanding of the outer solar system and has now pushed beyond into interstellar space. But what exactly is happening to Voyager 1 out there in the cosmic void? Could this be a response to the golden records it carries? Or has the probe encountered an alien civilization? Stick with us until the end as we explore these possibilities. 25 and 20 billion kilometers, these staggering distances mark how far NASA's Voyager 1 and Voyager 2 have traveled from the Sun since their launch in 1977. No human-made object has ever journeyed so deep into space. It's no surprise, then, that their mission through interstellar space has returned truly one-of-a-kind data. But let's not overlook how much Voyager 1 and 2 have also contributed to our understanding of the planets in our own solar system. Interestingly, these spacecraft, now considered the farthest outposts of humanity, were never meant to leave the solar system. Their original mission was simply to explore the outer planets, which remained largely mysterious at the time. Calling the accomplishments of the Voyager probes impressive would be an understatement. Voyager 1 and 2 captured invaluable data and images during their planetary flybys, many of which remain unmatched to this day. Notably, Voyager 2 is still the only spacecraft to have visited all 4 of the outer planets in our solar system. In fact, it holds the unique distinction of being the first and only probe to explore 4 planets: Jupiter, Saturn, Uranus, and Neptune. Voyager 2's encounters with Uranus and Neptune are particularly significant, as it remains our only direct source of detailed data on these distant ice giants. Thanks to this mission, we've learned about their unusual quadrupolar magnetic fields and their relatively small cores encased in thick shells of ice. But it's not just the planets that made the Voyager missions legendary. Their discoveries about moons are equally remarkable. No other mission has uncovered as many new natural satellites. Together, the Voyager probes identified 3 new moons around Jupiter, 4 around Saturn, 11 orbiting Uranus, and 6 accompanying Neptune. One of these moons, Io, orbiting Jupiter, was revealed to have active volcanoes, making it the first place beyond Earth where volcanic activity was observed. Adding to the list of milestones, Voyager 1 also became the first spacecraft to detect lightning on another planet, within Jupiter's vast, stormy atmosphere. Voyager 2 delivered breathtaking insights into the ring systems of Jupiter, Uranus, and Neptune. Most notably, it provided the first clues that a vast ocean may lie beneath the icy crust of Jupiter's moon Europa, possibly harboring an underwater world where extraterrestrial life could exist. The wonders of interstellar space continue to astonish scientists. There's no doubt that the discoveries and records set by the Voyager missions within our solar system were groundbreaking. However, those milestones are now part of history. Today, the Voyager spacecraft are making headlines for completely different reasons. As noted earlier, these veteran explorers have spent years traveling through interstellar space, where they've made equally remarkable observations. To truly appreciate their findings, it's helpful to recall a few basic facts. Our Sun is far from being a stationary source of light. Instead, it's a blazing furnace hurtling through space at an incredible speed of 725,000 kilometers per hour. It is surrounded by dynamic magnetic field lines, along which streams of plasma, known as solar winds, are continuously released. These solar winds flow throughout our solar system and eventually reach the interstellar medium. The space between stars is still filled with a mixture of particles, magnetic fields, and radiation that were released during and after the Big Bang. However, the solar wind and the interstellar medium don't blend smoothly. Instead, they interact more like oil and water. This separation creates a bubble around our Sun known as the heliosphere. In simple terms, it acts like a solar shield, protecting everything within it from most of the harmful cosmic radiation. According to Voyager data, the heliosphere stretches around 18 billion kilometers from the Sun. Its outer edge, called the heliopause, marks the boundary between our solar system and interstellar space. When Voyager 1 crossed into this boundary in 2012, it sparked surprise in the scientific community. The interstellar magnetic field turned out to be 2 to 3 times stronger than predicted, which meant the pressure from interstellar particles on the heliopause was up to 10 times greater than previously assumed. However, there was a limitation to what Voyager 1 could tell us. Its instrument for measuring plasma temperature had been non-functional since the 1980s. Thankfully, Voyager 2, equipped with a working version of this instrument, entered interstellar space 6 years later and provided deeper insights. It revealed how plasma behaves near the heliopause, slowing down, becoming denser, and heating up as it encounters the boundary. Despite being made of plasma, this material around Voyager 2 was found to be incredibly thin and uneven in composition, resulting in unexpectedly low temperatures. In contrast, the interstellar medium itself turned out to be far hotter than scientists anticipated, reaching temperatures close to 30,000 degrees. Voyager 2 also revealed that plasma from both sides of the heliopause appears to mix, forming a cosmic stream of low-energy particles that extends roughly 160 million kilometers across the boundary. Another surprising discovery came as the probes approached the heliopause. Voyager 1 had entered a relatively calm region about 1.3 billion kilometers out, where the solar wind had dramatically slowed. Voyager 2, however, encountered a much more dynamic zone, noticeably different from the one Voyager 1 had passed through. Patrick Kahn, a program scientist at NASA headquarters, described this difference as particularly unusual and stressed the need for even more comprehensive data in the future. But the mystery doesn't stop there. The entire heliosphere, the vast bubble created by the solar wind, remains largely unexplored, with direct observations from only 2 spacecraft. We still don't even know its true shape. It might be spherical, resemble a croissant, or trail off like a comet. And then there's the puzzling signal from Voyager 1. The last thing anyone wants in the vast emptiness of interstellar space is for a space probe to start acting unpredictably. But, as we know, the universe doesn't operate on our preferences. These days, it seems like you can practically set your watch by the technical issues that keep cropping up with Voyager 1 and 2. One such incident occurred a few years ago when Voyager 1 began transmitting a bizarre stream of data back to Earth, information that baffled scientists because it made no logical sense. As news of the glitch spread, the internet quickly lit up with theories. And, true to form, some were wildly imaginative. Suggestions ranged from the probe being intercepted by an alien civilization, to claims that it had been reprogrammed and sent back with a cosmic declaration of war. While Earth hasn't yet descended into a galaxy-wide conflict, the truth was still puzzling. Initially, it appeared that the data, specifically from the spacecraft's attitude articulation and control system, was completely random, suggesting a critical malfunction. Yet, strangely, the rest of the probe continued to operate as if nothing was wrong. This position control system plays a crucial role in keeping Voyager's main antenna accurately aligned with Earth, essential for maintaining communication across such an immense distance. So, it was particularly surprising that despite receiving faulty data from the AACS, Attitude Articulation and Control System, Voyager's scientific instruments continued to transmit normally, and the spacecraft still responded to commands from Earth. The signal strength also remained steady, suggesting the antenna was still properly pointed at our planet. After weeks of uncertainty, NASA engineers finally identified the problem behind Voyager's puzzling data. They discovered that the attitude control system itself was functioning correctly, except for one critical detail: it had been trying to transmit telemetry through an onboard computer that had been deactivated years ago. Because of this, the incoming data appeared as incoherent noise, causing confusion at mission control.